All right, so the last type of reaction we're going to look at is a combustion reaction. And a combustion reaction is a reaction with oxygen, where one of the reactants is oxygen gas, O2 gas. Now, understand that there are many reactions with oxygen gas as a reactant that are not combustion reactions. But we're going to talk, I mean, they all kind of fall under the same type of thing here. But for a combustion reaction, that's something burning. So that implies that the other reactant is burning, and there's heat being produced fairly quickly, and there's flame, and so on. Okay, so like your body does a lot of reactions with oxygen. Like you breathe in oxygen, and it's used to help break down some of the food, and oxygen's added to some of the stuff the things you eat and whatever. And clearly that's not combustion. There's not a bunch of fires going on inside your body. But it does fall under the fact that they're all oxidation reduction reactions. So combustion reactions, we'll talk about combustion reactions where it's reaction with oxygen. It is considered an oxidation reduction reaction. Okay, so if we're talking about compounds, organic compounds that contain only carbon and hydrogen, or carbon, hydrogen, and oxygen, when those combust, they produce only carbon dioxide and water, if it's a complete combustion. And to get a complete combustion, we need to ensure that there's enough oxygen around for all of the whatever is being combusted to burn cleanly, and there needs to be enough heat. If there's not those, then we get some other side products like carbon monoxide and things like that. But if there's plenty of oxygen and heat around, the thing that's being combusted will completely convert to carbon dioxide and water. Okay. So now that I've said this is an oxidation reduction reaction, we know that one of the reactants is being oxidized and one is being reduced. And before we could look at it and see, like, the metal was going from no charge, pure metal, to an ion, which makes it kind of easy to tell, right? Because it's got no charge, and then it's, let's say, a +2 ion. That means it's lost electrons, right? So those are kind of easy to tell. This isn't as easy, but we have a pretty simple rule. So when you're looking at your reactants, the one that increases the number of oxygens or decreases the number of hydrogens, that's the one being oxidized. So if we look at CH4 and O2, CH4 is going to CO2. It's increasing the number of oxygens, so it's being oxidized, or it's oxidation. That's the oxidation process. Okay, and the other one, so reduction would be a decrease in oxygens or an increase of hydrogens. So if we look at the oxygen, it goes to water, and it's gained hydrogens and lost an oxygen, so that's reduction. So in these type of oxidation reduction reactions, combustion reactions, the oxygen is typically going to be the thing that's going through reduction, and whatever is burning, whatever the other reactant is going to be going through oxidation, because you're putting oxygens on it. Okay. So when you're identifying combustion reactions, the way to tell is going to have O2 gas as one of the reactants. Oh, one other thing I wanted to say. So you would think that water would be a liquid, and sometimes in combustion reactions it's listed as a liquid, but it's typically assumed that there's enough heat and the temperature's gone up enough that the water is going to be a vapor during this process. That's why the water's a gas here. A lot of times it'll be listed as a liquid, but your book shows it as a gas, so I did that also.